Okay, so here we are in the second activity for Algebra 1 this week of distance learning. Hopefully you took a short break, and I'll try to make this video a little bit quicker than I did last time. So this activity is kind of a continuation of our exploration of what is a function. The previous one was called Guess My Rule, and this one is going to be called Commuting Times. So again, sign in Google if you're not already signed in. Choose your student account. Automatically there, so just hit join. And while we wait for the technology to load, again, feel free to pause and reflect throughout this video. I will tell you occasionally to do so. That way that we get some back and forth and you're not just watching me go through this on my own. The whole idea here is that I'm here to support you girls, and if you have any questions, feel free to contact me, either leave me a private message, comment in Google Classroom, or see me during my office hours, which this week, I know I'm going to be posting this a little late today, but my office hours this week will be every day, I think from 10 to 11, and I'll be on even until like 10 to 12. So if you have any questions at all, come hang out with me, and I can hopefully answer them. So let's get going. And this activity is going to be called Commuting Times. Go ahead and hit go. Okay, so first question. Commuting to school. How many minutes did it take you to get to school this morning? Okay, so well, this is kind of like we're in distance learning. Nobody's really going to school right now. But on a normal day, outside of this whole situation, how many minutes would it take you to get to school in the morning? Put in whatever your answer is, and hopefully you'll get some responses. You'll see some other things that your other students have put in. Let's see. For me, it usually takes me about 15 minutes. And your other responses will show up here. How many miles away from school do you live? I'm pretty close. I think I'm only about 5 miles away, something like that. I just am usually getting stuck in a little bit of traffic going down Washington Street. Again, this is on a regular school day, right? Okay, here are some commute times. Commuting means just driving back and forth. Commuting times and distances for your class, plus a few other students from outside of your class. The axes are not labeled. Let's see, which units should you use to label the x-axis? It looks like, what did I put in? I put in I said 15 minutes and 5 miles. So it looks like this is around 5. That should be the miles on the x-axis. And then 15 minutes on the, yeah, that makes sense, rather than the other way around. I put in 5 miles and 15 minutes as my unit. It's a graph. That's what it looks like. Other people's will hopefully on this graph as they get entered. According to your choice for the x-axis, your commute is 5 miles long and takes 15 minutes. Is this correct? Yes, and if it's not, go ahead and go back and switch your axis. Is the relationship between distance and time in this situation a function? So remember, a function means it's a relationship between two things. So in this case, distance, time, and it's a relationship where we always know what the output is going to be. Now, the output is on our axis. The x-axis is like our input. So, is this relationship a function? Do I always know how long it's going to take for some other things based on the distance that they live? Go ahead and answer that question and then pause the video and then come back in a few. Okay, so if you said yes, this is a function. You always know exactly how long it's going to take. You know what the output's going to be based on how far away someone lives. Then I'm sorry, you gotta rethink that. Because take a look. Um, take a look at these two dots, or just think about your own commute. Do you always know exactly how long it's going to take you to get to school? It's changing, right? You live the same distance away, but do you always know exactly how long it's going to take? And the answer to that is no, you don't, right? There's some variability. There's some changes. If you look at these two dots right here, let me highlight this. But these dots represent students who live the same distance away, but take different times. So no, it's not a function because we don't know exactly how long it will take. We don't know the output, which is the time, to get to school. For each distance, for each input away. Remember, I mean, you always know exactly what the output is going to be. So erase this line. And if you answered that, I think on the next on the next screen, I'll say that's right. This relationship is not a function. Take a look. Here's an example of why it's not a function. Both of them live 5.8 miles away, but on one day it took 17 minutes to get to school, and on the other day it took 14 minutes. And so we're not exactly sure. It's not always going to be the same time. We're not always going to have the same output. And a clear way to see that it's not a function is that these are both lying on the same x value, but different y values. Okay, let's model the relationship. So this is kind of similar to what we were doing when we took data in our statistics unit and we did some scatter plots. Let's draw a line that fits data. So hopefully there'll be more data when you do this. But for me, I'm just going to kind of drag this up here, try to fit the data a little bit. Doesn't have to be perfect. What does the model predict? The open orange represents your model's prediction for the time it takes you to go 5 miles to school. How does the model's prediction relate to your actual travel time? Well, for this, I had it go exactly through mine. So, the model says it looks like it will take 15 minutes. Now your model might be a little off. It's okay. The point of this is that the model, the line that we've drawn, always has an exact answer. So I drew a kind of said, okay, how long will it take someone who lives 20 miles away? How long will it take them to get to school? Based on this model, based on this line, well, I can say, okay, here's 20 miles away. I know exactly, in this model, it looks like maybe it'll take them 30 minutes to get to the school. That would be the y value. If we look in the next screen, there's a little comparison. So all I just said is not a function. There may be several different values of the dependent variable for the same value of the x, which is the dependent is the y. I'll just write that on here. The dependent variable, that's like our y value. For each value of the independent variable means our x value. So in our data set, we often get dots like these where we'll get two different values of our output for the same value of our input, our x. But a model like this line is a function. So the data is not a function, but the model is. What is a situation where you would want to answer this question? How much can commute of 5.8 miles take? You want to use that model to make a prediction, right? Make a prediction for how long it takes based on how far away someone lives. And it's important. Why is it important that this model is a function? Why are we talking about functions? Because a model like this, we always want to make sure that we have a single prediction for whatever our input is. That's the whole point. So if we had two different, if our model looked crazy, right, and we had two different predictions, then that wouldn't be a good model. It wouldn't, if it wasn't a function, that wouldn't be a good model, because we want to know, we want to be able to make an accurate prediction. How long will it take? What is this? We would want to use the data set to answer the question, how much time does a commute of 5.8 miles take? So this is a question about when would you use a model and when would you want to use a data set? Well, sometimes, right, you want to use the data itself if you want to know exactly how long it actually took someone. The model here would predict something different, right? This green line is our model. This is our model right here. I should really have put my tablet up. But this green line is our model. The blue dots are our actual data. So when would you actually want to use the, when would you want to look at the actual data to answer this question instead? Well, if you wanted to know the actual, how long it actually took someone, right? The actual answer for maybe one person, as opposed to making a prediction for someone else who lives the same distance away. And we look at the data. So a difference here. Two important things to know about functions and data sets. Scatter plots are useful. They represent in the data. We can look at all of it and try to look at it and see if there's a pattern. That's what we did when we were making scatter plots. Functions, like this line, give us a way to model data and come up with one prediction, one answer for that question. So the whole point of functions, why do we use functions, why are we talking about functions, is to make sure that we have one answer, one output, one prediction for our question. Okay, which one doesn't belong? Which of these relationships seem from the rest of you? This is a little open-ended. Why don't you pick one and see if you can explain why to you it's different. Go ahead, pause. Okay, so in reality, I mean, you could pick any one of these and come up with a good reason for why it's different. For example, this first one isn't a line. It seems like it's a curve. You can ask, is that still a function? Sure, as long as each input. We could say, what about this one? Well, maybe it's going down, right? It's the only one. All the others are all going up. What about this one? This one I would say is different because, it's not. If we look, there's a lot of the dots of the scatter plots that are on top of one another. If they're on top of one another, then it's not a function because we've got two different outputs for the same input. You could have picked this one because it's a line. It looks like it's a model as opposed to a data set. So it's really up to you. I'm personally just going to pick this one and say this data set, not a function. But you could have picked any one. All right, so I'm going to pause the video now, and then when I come back, I'm going to add onto it. We're going to look at some practice problems in IXL and make sure that we can tell the difference between what is a function and what is not a function.